Okay, good morning. Today's session, we are going to discuss about the uniform cost search methodology. So this technique is one of the important technique that should be supported for the uniform cost search. So how we should be utilized for solving this the problem. So already we discussed technique for solving the uninformed cost searching method. We are going to discuss about the uniform cost search. So what do you mean by the uniform is optimally one with their depth also. So how be able to process these steps. So I will explaining with the one simple examples. So you may easily understand the on the problem of the uniform cost search. So uniform cost search, the first path. So this is the way we are able one simple problem. So you just note it down. So consider this the problem. So what is the problem is that now here you just see the graph. Okay, so what is the graph now? There is A, B, there is here so many six vertices also there. Each and every vertices are connected with the edges. So here A to B, the edges is 5, A to C is 9, and B to E is 8, and B to D is 2, and D to E is 7, and D to G is 6, and C to G is 12. So these are all the edges are assigned between the two different the vertices. So you just note it down. And here, so how the uniform cast search, the process that should start it. So as the setup. So how we are going to do this? So this is our first question. So in the first step, we just starts with the from this graph. You just identify the which node is an initial node and which one is the final node. So A is initial node and G is the final node. So let us discuss how the uniform cost search that should the proceed step by step. So first step is start from the node A and expand none. So here. Start from the node A. So you just okay, you just take it out one node that is called as an A. So you can note it down, and the step two, the frontier. So that is the node A has to be taken here. So from this node, we are going to perform the expand operation. So whether we are able to expand the node A, or what do you mean by expansion is we need to find out any other children's available in the particular node. So for considering the node A, so we may have the two different nodes. One is called as an B, another one is called as an C. So B node and C node is also there. So here you just see this, there is A to B and A to C also. So A to B is 5 and A to C is 9. So you just note it down. Here you just see this. Okay, got my point. So what I am telling is, so you just identify the node. So once you identified, so you may able to expand the node, expand the node. So here you can expand the node A. So you may have the two different nodes. That is, one is called as an B, another one is called as an C. So what is the cost that should be reached to traverse from node A to B is 5. The node, what is the cost, uniform cost from A to C is 9. So from this nodes, we are able to find out which one is we just identify the lowest node that is called as an B here, AB. So after this, select the lowest node as B here, and this is step 3 is over, and the step 4 is so we are able to find out the frontier. There is a frontier means uh, uh, again B, you just take it as the B means you can identify the take the node and then expand B. So expand B. So the B may have the two different options. That is, one is called as an 8 and 2. So you can include this here also. So for example, what I am asking is what is the uniform cost that should be taken to reach from A to E. A to E is 5 plus 8 is 13. So 5 plus 8 is 13. So this path will take and the cost is 13. So here next one is A to D. A to D is 5 plus 2 is 7. So you just noted, and A to C is 9. So which one is A and I? So you may have the three different options. That is, first one is A, B, D is one path, and A, B, E is another path, and A, C is the third path. So in the first path, the uniform cost value is 7 only. So in the second path, the uniform cost value is 13, and the third path may have the uniform cost value is 9. So from these three values, you just find the very minimal value is D. So you just choose it on, and from this D, you can find out whether the node D is an gold state or that should be a non-gold state. So this is not a gold state. So again, I am going to expand further. There is a expand of D means we may have the two different option. One is E and G. So you can see this E and G. Okay, so you just note down this kind of things. E and G. So, so you just note down this. Okay. So, for example, suppose E and G is there. So, suppose I want to traverse from A to E. So, that should be taken as 13. 13 here. Sorry. Mm, A, B, D, E. A, B, D, E. There is 7, 7 plus, there is 14. 14 here, A, B, D, E. A, B, D, E. So you can see this A, B, D, E is 5, 2, 7. 5 plus 2 plus 7 is 14. Okay, so 14 here. Another one more thing is A, B, D, G. A, B, D, G is 7 plus 6 is 13. So 13 you can note it down. Another one more thing is A, B, E. So here A, B, E is 8 plus 5 is 13 and AC is 9. Okay, so you just note it down 9, 9, 13, 14 and 13. So which one is having the minimum value is C. So C may have the that is a minimum node. So you just in the step 5. So we have extended further. So we have to extend further. So here C is there now. So this should be a minimum. So C means C tends to 12, 12 and G. So actually this is an G if we are including here. So 9 plus 1, 21. So automatically we may have the two different path for reaching the node G. One is A, B, D, G. That is the path is 13. Another one is A, C, G. A, C, G. A, C, G. That is called as an 21. So which one is minimum? So you just take it out. So this is one more thing. This is a way we are able to find out the uniform cost strategy of the given graph. Another one is a uniform cost search. That should be how we are going to be able to implement that with the help of this the path. So we may have the four different options. One is complete, time, space, and the optimal. So complete means yes, means if the step cost may be greater or equal to empty. So or otherwise it can get stuck in this infinite loop. Next one is time. So what I mean by time is there is number of nodes with the path cost is less than the cost of the optimal solution. So we just find the cost of the number of nodes that should be less than the cost of the optimal node. So next one is the space, number of nodes on the paths with the path cost less than the cost of the optimal solution. So you just note it down. And whether it should be apply there is a obtain the very optimal solution. Yes, the first step, any step of the cost we are getting the in the cost value. So you just before, if you are writing the uniform cast search, you just focus on this the three different aspects. You just focus. So first one is what in by why we go for this the uniform cast search, and what is the different how we should be deviated from BFS and DFS. And so, what is the main objective of this the uniform cast search? And next one is how we are going to find out the uniform cast search from the given example. And finally, whether we are able to find out the time and space complexity. That is, time complexity means number of nodes within the path cost is less than the cost of the optimal search. So, number of nodes on the path with the path cost less than the cost of the optimal solution. And the optimal solution means for any the step cost. So, we need to include all those things also. So, this is a way we are able to find out the solution of this the uniform cast search methodology. So, so any doubts regarding this, you just ask me. So we will clear your doubts also. Is it clear, na? So, so you just note down this. So this is the way we are able to find out for this the process. Okay, thank you.